Hi and welcome to this brand new solution video of February-March 2024 paper 42 of Cambridge International Examinations A-Level Mathematics. If you like this video, please give it a thumbs up and share with your friends and subscribe to Math United. The question number 1 talks about the displacement of a particle at time t seconds after leaving a fixed point O is s meters. The diagram shows the displacement time graph. Okay, the graph consists 4 straight line segments. The particle moves 50 meters in first 10 seconds, then travels at 2 meters per second for a period of 10 seconds. So here the gradient of ST graph is velocity, right? And velocity is 2 meters per second. For the period of 10 seconds, the particle then comes to the rest for a period of 20 seconds from 20 to 40 clearly, and then comes to rest in next 20 seconds. Okay. Find the velocity of the particle during the last 20 seconds of its motion. Okay. We can use, since it's a straight line, that means this velocity is exactly same, constant. So if somehow we can find this level, how much was the distance at this level, from that level to coming back to the original position, we know that distance, and we know the time, we can find the velocity easily because it's a straight line, constant velocity, no acceleration, so it'll be easy. First we have to find this level, and that we can find how much distance is being traveled here. Since it's a straight line, it's the same velocity, no acceleration, we can use a simple distance equal to velocity or speed times time. Only in the case of constant velocity in same direction, okay? So, which will be, the velocity is how much? 2 meter per second they have given, time is 20 seconds, sorry, 10 seconds, 10 to 20, 10 seconds, so it becomes 20 meters, right? That means this level is 70 meters from here to here, because during this period 20 meters is being traveled. Now from 70 the particle comes back to original position, that is 0 meters from its original position. So total distance now is 70. In last 20 seconds I'm talking about now. Distance is 70, right? Time is 20 seconds. Since the gradient is going to be negative here, let's not take the risk of the speed formula. We'll use the gradient formula. So what are the coordinates of this one? It is 40, 70, and this one is 60, 0. So gradient of an ST graph gives you velocity. So velocity will be the gradient of this. So I will say y2, or rather in this case s2 minus, gradient will be s2 minus s1 over t2 minus t1. That will be the gradient. So s2 is 70 minus 0 over t2, 40 minus 60. Yeah. So how much that will be? 70 divided by minus 20 gives me minus 3.5 meters per second. That's the velocity with a negative sign. Okay, sketch the velocity time graph for the motion. Okay, so let me draw it here on top of this. So v will be in this case here, t will be here. Okay, so I need some space, that's why I have moved it. Okay, so now it is a straight line, that means the velocity here will be exactly same. Okay, and what will be the velocity? In 10 seconds 50 meters was traveled. So if this is, say this is 1, this is 2, this is 3, and this is 4 meters per second, right? So it is 2.5 till 10. So starting from here reaching here, so 2.5 and constant, okay, not changing at all. So up to 10 seconds it will be 2.5 here. Okay. Then from here to here it traveled 20 meters, and velocity was given 2 meters per second rather. So 2 meters per second. So we will do 2 meters per second for next 10 seconds. Then it is stationary for from 20 to 40 seconds. So we will draw 20 to 40 seconds here. 0, no velocity at all. And then negative 3.5. So we'll have to go in negative zone now. 1, 2, 3, 4. So we will be at 3.5 somewhere here, negative at here. So we will draw again a vertical dotted line, and this will be negative 3.5 for next 20 seconds. This is the VT graph. Question number 2. A particle is projected vertically upwards from the horizontal ground. Okay. This is the ground and it is projected upwards. Okay. The speed of the particle after 2 seconds is 5 meters per second, and it is traveling downwards. So it goes up and obviously comes down. Somewhere its speed is 5 meters per second, and the time from the projection and reaching this point is 2 seconds. Find the speed of the projection of the particle. What was the projection speed? So u equal to what? This is the question. So we know that v is equal to u plus at, right? V, the final velocity at this moment was 5 meters but downwards. So downwards I'll take it as negative. So minus 5. So u is obviously positive because it's going up, and whatever we'll get will be the answer. Plus a, in this case it is in air, and in air the acceleration due to gravity works, so it will be minus 10. Here time is 2 seconds. We'll get u. So minus 5 equal to u minus 20. 20 comes to the other side, so minus 5 plus 20 is equal to u. So u comes out to be 15 meters per second upwards. They said speed, so 15 meters per second is enough. Okay, next. Find the distance traveled by the particle between the two times at which its speed is 10 meters per second. Speed again. Alright. So, while going up, there will be, because it was projected at 15 meters per second, somewhere here the speed will be 10 meters per second. And somewhere here also the speed will be 10 meters per second. Right, but it will be downwards, this will be upwards, and they're saying find the distance traveled by the particle between the two times. So how much is the distance traveled up and down? So in this case u is 10 meters per second. Okay, v is minus 10 meters per second. Acceleration is again minus 10 because it is coming downwards. So 10 meters per second square, due to gravity it is coming down. Alright, and we have to find s. What is the distance traveled, right? But in this case we'll get displacement. Since I'm taking the directions, we will not get distance, right? So let's do what? Let's take into two parts. U is 10 meters per second going up. Let's see how much distance it goes up in this case, right? So I will use this formula, which is v square equal to u square plus 2as. This will give me the displacement, which I'll convert to distance because it is up to when it is going up and stopping here. I'm going this particular distance 10 meters per second here and 0 meters per second at the top. So top, it is 0 equal to 10 square plus 2a. This time it will be minus 10, right? Yeah, minus 10. And s we have to find out. So 10 square is 100, and when it goes to the left side becomes negative minus 20s. So s is minus 100 over minus 20, which is 5 meters. Okay, this time now it will become v equal to minus 10, but u is 0 because it is turning back and coming to 10 meters per second in this direction. But keep in mind, this will be exactly same distance. It is assumed, but let's see if we get the same thing again. So we'll use the same formula again. This times v is minus 10 because it is squared. We'll add minus 10 squared. So equal to 0 square plus 2 times, and g is also done downwards, so minus 10 and s. So what is this? 100 equal to minus 20s, and s is equal to minus 100 over 20. Again, see, we got 5 meters, negative 5 meters this time because it is downwards. So because of this, we will have to take the absolute part of this because we want distance. So total distance will be 5 plus absolute of negative 5, which is 10 meters is the distance traveled by this particle. Question number 3. A crate of mass 600 kg is being pulled up a line of greater slope of a rough plane at a constant speed of 2 meters per second. So this is the rough plane. This is the crate which is being pulled. Its weight is 6,000 newtons because the mass is 600 kilograms. So 10 times that, 6,000 newtons is the weight. Okay, its constant speed, velocity is 2 meters per second. By a rope attached to a winch. Okay, winch is a machine, so let's say that is the machine motor which is rolling this thread on it, rope on it, so it goes up. Okay, inclined at 30 degrees, so this angle is 30 degrees, okay, to the horizontal, and the rope is parallel to the plane. Okay, easy for us. The winch is working at a constant rate of 8 kilowatts, so power is 8,000 watts. We don't use kilowatt, we use watts, so kilo has to be converted to 1000. All right, find the coefficient of friction between the crate and the plane. Okay, since the speed is constant, that means, and it is power is also constant, which means the applied force is also constant, which is power divided by the speed at which it is traveling, which is 8,000 divided by 2, 4,000 newtons. So this way the applied force is 4,000 newton. Since it is going at a constant speed, that means the forces on the other side are also equal to 4,000. What are the forces? One is the component of this weight in this direction, which is 6,000 sine 30 degrees. Sine component is always along the greater slope. There will be one more force because of the friction. So which will be force of friction. Mu is the coefficient of friction, and R is the normal contact force in this direction, which will be equal to the force in this direction, 6,000 cos 30. So this is sine component of the weight, this is cos component, which will be equal to the R, and I'll replace that with this. Since these two forces are equal, that's why it is traveling at a constant speed, so we'll equate them. So 4,000 will be equal to mu R. R is 6,000. Let me write 6,000 cos 30 degrees. and then 6000 sine 30 also sine 30 degrees. So these two forces are equal to 4000. 4000 stays 4000 equal to cos 30 is square root 3 over 2. So mu 6000 square root 3 over 2 plus 6000 sine 30 is 1/2. So it cancels out 3000 and goes to the left side with 4000. So since it is adding on the right side, becomes negative here, equal to, this also cancels out 3000. So 3000 square root 3 over and mu. We have to find coefficient of friction, which is mu. So now 4000 minus 3000 is 1000 equal to 3000 square root 3 mu. So mu will be 1000 divided by 3000 square root 3. We can cancel 3 zeros first, and then 1 over 3 square root 3 we'll put in our calculator and I'll find it out. By the time I do this, I would like you to request you to like this video, share with your friends, and subscribe to Math United. 1 over 3 square root 3 gives me 0.1924. So 0.192. This is the answer, 3 second figures, the value of mu. 4 coplanar forces act at a point 1, 2, 3, 4. Okay. The magnitudes of the forces are F Newton, this one, 2F Newton, 3F Newton, and 30 Newtons. The direction of forces are shown in the diagram. So this is theta, and I forgot to write, this one was 45 degrees. Okay. Given that the forces are in equilibrium, find the value of F and the value of theta. In such cases, we should always look for the vertical and, let's say, resultant force and horizontal resultant force. So first we'll resolve these forces in vertical and horizontal component, the ones which are tilted. This is straight, right, horizontal, so no need to touch this. This is vertical, no need to touch this. This 2F is the one which is tilted, and because the angle is here, I will write the vertical one will become 2F cos 45 here, and here it will become 2F sine 45. Wherever is the angle, that becomes cos component. Wherever the opposite side of the force becomes sine component. Similarly here, the angle is here, so this will become 30 cos theta, and the one which is going up on the opposite side of the force becomes 30 sine theta. Now there is no need to look at this force or this force, we have components now. So vertical resultant will be, let me make some space here, okay, F plus 2F cos 45 equal to 30 sine theta, which is upwards, because they are balanced in equilibrium, they are equal. So F plus 2F cos 45 is square root 2 over 2. So this 2 and 2 cancel, equal to 30 sine theta, which is how much? 1 plus square root 2, right? Because this has cancelled. So I take F common. F is in both. So here if F is out, 1 left. F is out, square root 2 left. Okay. Equal to 3 sine theta. Okay. Let's keep it like this. Go to the horizontal one, where 30 cos theta will be equal to 3F plus 2F sine 45. Okay, so 30 cos theta equal to 3f plus 2f, and this 2 sine 45 is also exactly same, square root 2 over 2. Cancel. So what do we get? We get 30 cos theta equal to, and if I take f common again, I get what? 3 plus square root f, not 5, square root 2f, yeah, square root 2, this one is square root 2, f is common, 3 plus square root 2. Okay, now we got one equation here and one equation here. Let's divide. Sine should be on top, so 1 divided by 2, so that it becomes tan. So did I have 3 here? Okay, 30 and 30. I'm sorry. So this should have been 30. So I will divide 30 sine theta, this one on the left side, equal to 1 plus square root 2 f, right? Divide by left side of this one, 30 cos theta divided by 3 plus square root 2 f. So that was the purpose. F and f will cancel here. We got rid of one variable. The sine theta over 30 and 30 also cancel out. Sine theta over cos theta will be tan theta equal to 1 plus square root 2 over 3 plus square root 2. Theta will be tan inverse of 1 plus square root 2 over 3 plus square root 2. Let me use my calculator for this. By the time I am doing this, I would request you to like this video, share with your friends, and subscribe to Math United. What I'm getting here is 28.675. So one decimal place for angle, it will be 28.7 degrees. So we had to find theta. We found theta. Now we have to find f. So for f, we can use either this one or this one, any equation. Let me use this one, which is easier. 1 plus square root 2 f equal to 30 sine 28.7 degrees now. Yeah, we got a theta, and f is the only one left. So f will be equal to 30 sine 28.7 degrees over 1 plus square root 2. Comes out to be 5.967. So I'll write 5.97 newtons. That is the value of f. Given that the forces are in equilibrium, find the value of f and theta. We found f and theta. Question number 5. A particle moves in a straight line starting from the point O. Okay, so this is O and it is traveling in a straight line. The velocity v meters per second of the particle t seconds after leaving O is given by this. This is the velocity till 4 seconds. Okay, you may assume that the velocity of the particle is positive. That means it's going in positive direction for t equal to half. So if t is equal to half here, so it is moving in positive direction, is 0 here, that means it is changing direction, and it is negative 40 is greater than half, so more than half, it is going in opposite direction here. Okay, find the distance traveled between t equal to 0 and half. We have the equation for velocity. We want distance, and since they are saying that it is changing its direction at half, they have saved our time. We will just find this distance from here to here, means displacement is the distance. So for displacement, we will write integration of velocity equation. So 0 to half t cube minus 4.5, let me write here, or t square plus 1 dt. So if I integrate this, what do I get? I get t4 over 4 minus 4.5 t cube over 3 and plus t. This is the integration of this, and we'll write plus c also, from 0 to half. Now to find displacement or distance in this case, we substitute half and 0. All of them have t. That means there is no point in substituting 0 because the whole thing will be 0, so we'll substitute just half. So half to the power 4 divided by 4 minus, let's cancel this, 3 and 4.5 will be 1.5. So 1.5 to the power, then half to the power 3 and plus half. Okay, c will be cancelled when I'll substitute 0, so c is gone. Just we have to do this and we will get our answer. It will be how much? 1 over 16 times 4, 64, minus 1.5 over 8. 2 cube is 8, 1 cube is 1, so multiplied with 1.5 and plus half. Let me see how much it's going to be using my calculator. By the time I do this, I would request you to like this video, share with your friends, and subscribe to Math United. Okay, what I'm getting here is in fractions 21 over 64 or 0.328 meters. Only very short distance it went in this direction and then change its sign. So distance gone. Okay. Find the positive value of t at which the acceleration is 0. So acceleration, how can I find acceleration from velocity equation? I can differentiate it. So let me differentiate. So let's do it here. So dv over dt will be the acceleration. It has to be equal to 0. So what is the differentiation of the given equation, which is v cube, t cube. So the differentiation of t cube will be 3t square minus 9 over 2, and the differentiation of t square will be 2t, and plus 1 is differentiation will be 0, so gone, no need to write it, so this cancels. So 0 is equal to 3t square minus 9t. And if I want to find t, I'll take 3t common from this. So 0 equal to 3t and t minus 3. This gives us t equal to 0, and this gives us t equal to 3, and we'll accept this because they said positive. Positive, find the positive value of t. 0 is neither positive nor negative, so t equal to 3 they mean. And obviously we will not find the distance from here because it is, we know it is at the starting place only. Okay, so t equal to 3. Now we have our integration already with us. We will just substitute from half because it is up to half. Can you see? It is from 0 to half. We got this distance. Now we'll write from half. Rather, let me straight away write the answer of integration. So it will be from half to 3 now, because 3 is the place where acceleration is 0 and there is no change of direction in that. Clearly they have said it's positive for t is greater than half. Sorry, it is negative for t greater than half. No changing of direction after that till 4, and we got 3 which is less than 4, so we don't have to worry about change of direction. Okay, so it was t4 over 4 minus 4.5 t cube over 3 plus t and plus c. Let's substitute. Half we already know, but 3 we will substitute. Okay, so first 3 to the power 4 over 4 minus 1.5. We had to already cancel this. 1.5 t cube, 3 cube plus 3 and plus C minus, we'll substitute half and we'll get exactly same what we got here. What? 21 over 64, right? When we substitute half and plus C. This C and this C gets cancelled, that's why we can ignore it. And now we can simply put our values here. So 81 over 4 minus 27 times 1.5 plus 3, and we can bring it here minus 21 over 64. Let's see what I get from my calculator here. It comes out to be minus 17.57, which means this particle moves a lot in the direction, very, very long distance as compared to this one in this direction, which is 17.57, right? But we'll have to find the distance, right? Not displacement. That means we'll have to ignore the sign here. So total distance will be absolute of minus 17.57, which we have got now, plus 0.328 we got earlier. Total distance is this, which will be about 17.9, yeah, 3 significant figures, 17.9 meters. Question number 6. A car of mass 1800 kg is towing a trailer of mass 300 kg up a straight load incline at an angle where sine A is 0.05 rather. So let's do it. This is the car. Its weight is 18,000 newtons. 1800 times 10. It is towing a trailer. Its weight will be 3,000 newtons. Okay, this is angle A. Okay, the car and the trailer are connected by two bar, okay, parallel to the road. There is a resistance of 800 newtons acting on the car. So there is a resistance of 800 newtons in this direction, and resistance of F newtons here. So F newtons is working on this trailer. The driving force of the car's engine is 3000 newtons. So car is going up, right? Up 3000 newtons. It is given that F is 100. So they have given the value 100 newtons for this. Find the acceleration of the car and the tension in the tow bar. Okay, so we know that MA is equal to the difference of applied force and resistive force. Mass, because both masses are traveling, so we'll add their masses, which is 800 plus 300, 2100 times A equal to applied force is just 1, which is 3000 newtons. Let me not write newtons. And resistive forces, 800 newtons 1. Let me add all of them. 800 newtons is resisting, plus 100 is also resisting, plus there will be sine component of the weight in this direction for both of them. Let's count them as one mass. So it becomes 21,000. 21,000 sine of A. It is always the sine component which works downwards, right? So sine component of this as well as this will make it 21,000 sine A. And sine A's value is given here. Everything is known to us. Only this A is different from this A, okay? This is acceleration, this is angle. So 2100 A is equal to 3000 minus 900 plus 21,000 times sine A is given as 0.05. So 2100 A is 3000 minus 921 0.05 will be 1950 because 1050 plus 900 now. Okay, so 2100 A equal to 3000 minus 1950, which will be 1050. A is 1050 divided by 2100, which is 0.5, exactly half of this. Got the acceleration. Now we want tension in this bar. So we can take either this mass or this mass. I'll take this one because it has less number of forces, and I will apply the same formula here. MA, mass in this case is 300 kilograms. So 300, acceleration we just got, A, equal to applied force for this particular mass is just the tension. This 3004 is for this mass, is touching this mass. So that will be taken care by this T here. So T minus, we have 100 in the opposite direction, and the sine component of this mass only, which will be 3000 sine A. Or let me write the value straight away, 0.05. Okay, so this is 150 equal to T minus 100 plus, this will be 150 again, 250. When it goes to the left side, it becomes positive, it's negative here. So 150 plus 250 is equal to T. So that comes out to be 400 newtons. That's the tension in the bar. Okay. Next one, B, it is given instead that the total work done by against F in moving a distance of 50 meters up the road is 6,000 joules. So this is the second mass which had a resistance of F, right? And distance is 50 meters and 6,000 joules is the work done in overcoming this F, right? Against F. All right. So we know that energy or work done is force times distance. Force is F, unknown. Distance traveled is 50 meters, is equal to 6,000 joules. So are they asking F? No. So let's find F first. 6,000 divided by 50, which is 120 newtons instead, not 100 anymore. The speed of the car at the start of the 50 meters is 20 meters per second. So U is 20 meters per second. Use energy method to find the speed of the car at the end of 50 meters. Okay. So energy method they're saying. So energy formula is that the work done by the applied force is equal to the sum of the work done against resistance plus change in potential energy plus change in kinetic energy. Right? What is the applied force? Let's see. Go back to the question again. Applied force was 3000 newtons. Yeah? And it went for 50 meters. So 3000 times 50 again, because it is force times distance. So this will be applied work. Work done against resistance will be, there are two forces now. One is 120 and the other one was 800. So it becomes 800 plus 120 and multiplied by 50 again. This is the work done against resistance. Now I will not take the sine component because that is taken care of by the potential energy difference. So I will not count them as resistances anymore. This will take care of it. So what is the formula for change in potential energy? It is M Mass of the both the truck and trailer is how much? 13,000, yeah, 13 and 800, right? So it is 1800 and 300. 1800 plus 300. And then G. So basically it is mg final height minus initial height. Okay, so m we have done here. What was the final height? Final height will be, okay, let's see how much this is 50 meters it went. Okay, both of them went 50 meters, right? This is A, this is the height they gained from here to here. And we know that sine A is h over 50. So h equal to 50 sine A. So that becomes our final height, right? So final height is 50 and sine A is given to us, which is 0.05. And this was the initial height here at the ground, so minus 0. So we have used this formula. M, okay, I did not multiply by 10. So let me multiply. G. This is G and this is the difference of H. Alright. Now, change in kinetic energy plus the formula for change in kinetic energy. Let me have more space here. Okay, change in kinetic energy is half m final velocity square minus initial velocity square. Okay, so it will be half, and m is again the same, which is 1800 plus 300. Let's write it at 2100 this time. Final velocity we don't know. I think they are asking find the speed of the car at the end of 50 meters. So final velocity they are asking, but initial is given 20 meters per second, right? So we will write here final velocity square minus 20 square. We have used this formula as well. Everything is there. Very, very carefully we have to use our calculator and find this. I can use little bit of mental math also. So there are 15 and 4 zeros equal to this is 920 times 50 plus 2100 times 50 times 0.05 will be 2.5 meter. 2.5 will be the resultant of this one. That is the final height, and times 10. Okay, this also cancels. 1050 v square minus 400. So it becomes 151,234 equal to 92 times 460, 460, 12. Okay, 25 times 2100 will be 52500 plus 1050 v square minus 400. Okay, let's add these two and subtract from 150,000, yeah, minus 98,500 equal to 1050 v square minus 400. This will be 51,500, and we can cross multiply this by 1550 dividing here. We are left with only v square minus 400. So 51500 divided by 1050 plus 400 equal to v square, and now we can square root this. V will be equal to square root of 51500 over 1050 plus 400. Let's put this in our calculator and we'll get our answer. By the time I'm doing this, I would request you to like this video, share with your friends and subscribe to Math United. So what I'm getting here is 21.1907. So I can write 21.2 meters per second. Question number 7. The diagram shows two particles P and Q lie on the line of greatest slope of a plane ABC, A, B and C. Particles P and Q each of mass m, so their mass is m. That means this will have a weight of 10 times m. This will also have a mass weight of 10 m. Okay, sine theta is 0.6. So 0.6 I can write as 3 over 5. Okay, it's the same thing. The length of the AB is 0.75 meters, then 3.25 meters. The section AB of the plane is smooth, so here mu is 0. And the section BC is rough. The coefficient of friction between each particle and the section BC is 0.25. Okay, particle P is released from rest at A. Okay, at the same time Q is released from P. Alright, verify that the particles P reaches 0.5 seconds. Verify, after it is released with the speed of 3 meters per second. So particle B, this particle P reaches B. That means a distance of 0.75 meters after it's released with the speed of 3 meters per second. Since we have to verify, we can use a formula where we can use these values, because we have to verify, we don't have to find out. So V equal to U plus AT. Hopefully this will help. We have to verify that this is 3 meters per second when it was released from rest, and the acceleration is not known. No. So we have to find acceleration first. Okay, for only P particle. So what will be bringing it down, because it is released, no force is there, only the sine component of 10 m. So ma is equal to applied force minus resistive force. So m is m a, we have to find out, equal to applied force will be the sine component of this, which is 10 m sine theta. There is no resistive force because it is smooth, right? So this is the one. So A becomes 10 m sine theta is how much? 3 over 5, and divide by m, because m goes to other side and becomes denominator and cancels this. So 5 times 2 is 10 and 2 times 3, 6 meters per second is the acceleration. A equal to 6 meters per second square. Time is given to us 0.5 second. And yes, we verified 3 is equal to 3. It is working. Alright. Next part. The two particles coalesce when they collide. Of course, because this one is rough, so it will move slow, this will move fast, and they will collide somewhere here and then coalesce. Okay. The coefficient of friction between the combined particle plane is still 0.25. Of course, they have already mentioned that one. Find the time it takes from the instant the particles collide until the combined particles reach C. So they are confirming that they will collide before this distance of 3.25, somewhere here, and then they will reach C. So from where they are asking, time it takes from the instant the particles collide until the combined particles reach C. So first we'll see when do they collide. Okay. So let's say that they collide somewhere here, okay? And from here to here, the distance is x. I don't know how much is that distance, but we'll say this is x, okay? So we'll write for P here and for Q here. We will write, we'll use the formula S equal to UT plus half AT square. Okay, how much displacement P had? It has 0.75 plus x, right? Because they collided here, so it traveled 0.75 extra. So 0.75 plus x is equal to, since they started from rest, this will be 0, half, and we already got the acceleration for it, which was 6. But there is a problem. Same acceleration will not be. Therefore, distance x, that means we'll have to separate the two. So we will just find how much time it takes to reach here. So 0 plus half acceleration is 6. Yeah, that's what we got here. And t square. So 0.75, and this 2 will multiply, 0 is gone. So 2 will multiply there, 1.5, and 6 will divide. Equal to t square. Rather, we could have done this one here. So, okay, we done, no problem. 1 over 4 is t square. So t comes out to be square root of 1/4. We can't take the negative, so half second. Half second it takes to reach to point B. Okay, but I'll have to remove Q from here, because after that we will see in half second how far had the particle Q traveled in that half second of this one. So we will find acceleration for particle Q also, which will be applicable to both now after that, because both of them have same mass, so they will have same acceleration separately here. So first MA for this is M and different A equal to, applied force will again be 10m sine theta, but there will be a resistive force now, minus mu, which is 0.25 given, and the cos component of this times 10m cos theta, which is the contact force here. So let me say this one. This is also applicable to the other particle beyond B. Okay, so this is I'm finding for both. So this is MA equal to 10m 3 over 5 minus 0.25 times 10m, and if cos theta is to be found when the sine theta is 3 over 5, by Pythagorean we'll find that this is 4, so it will be 4 over 5. So m is present in all, so let's divide all by m and get rid of it. Gone. We can divide by the whole equation by the same number. So A is 6 minus 2 again. So 0.25 times 8 is 2, which is 4 meters per second square. Okay, so that is the acceleration for particle B. So let's use that acceleration to find how much it has traveled for that half second. So S equal to UT, which is half, plus half acceleration we know now, 4 t square. Okay, this is 0. S equal to 1 over 2 will square will be 1 over 4. So this and this also cancel out. So plus half. So it means by the time the other one, the particle P traveled 0.75 meters, particle Q had just traveled 0.5 meters. So now the difference between them was 0. How much? It has reached here, and so 0.5 meter is the distance. After that, it depends on their current velocity. When will they collide? Okay. So, new situation. Particle P is at B now. 0.5 meter ahead is particle Q. Both have same acceleration, but P's velocity will be more than Q because it has come through a smooth plane. Let's see what was the velocity of this one. V equal to U plus AT. So V equal to 0 plus 6 times half. Yeah, so which is 3 meters per second. Okay, this is for P. What about Q? What was its velocity when it was here? Which will be U plus AT again. So 0 plus 4 times half. Okay, so it will cancel. So it is 2 meters per second. Now they will accelerate with same rate because both are exactly same mass and their coefficient of friction is same for both. But because this has higher velocity, it will reach to Q after some time. So let's see after this point. After this point, when will they meet again? And this time let's take S equal to U T plus half AT square. This formula we can take. We don't know when will they collide, so we don't know the T also. But we'll take that into account now. Suppose they meet at this place, which is X meters from where Q has reached now. Okay, 0.5 and then X after that. So for P, what will be the situation for P? This one, it will travel 0.5 plus X distance with a U of 3 meters per second. Yeah, at this point its speed is 3 meters per second. Time we don't know. Half, but its acceleration will be 4 now. Okay, T square. Right? So let's simplify this if we can. 0.5 plus X equal to 3T plus 2T square. Okay. What about Q? It will travel just X. So X equal to its speed is 2T. Yeah, initial speed is 2. So 2 meters per second. 2T plus half AT square, it will be 2T square again. So now X has this value. I will substitute it here in this one. So let's see what difference it makes. 0.5 plus, in place of X, I will write 2T plus 2T square equal to 3T plus 2T square. 2T square is common in both sides. We can cancel them out. So 2T can come there. So 0.5 equal to 3T minus 2T. So T is again half second. After half a second, this P will catch up with Q. That's what it means. Right? Let's see what the question is. Find the time that it takes from the instant the particles collide after this 0.5 seconds until the combined particle reaches C. So what is the value of x? That we have to find out. Why? Because we have to reduce this 0.5 and this x from the distance which was there originally. Originally it was 3.25 meters. From there these two distances need to go. So I'll find x now. X equal to 2 times 0.5 plus 2 times 0.5 square. So x is 1 meter plus 0.25 times 2, 0.5, 1.5 meters. Okay. So 0.5 here and this is 1.5 meters. That means total 2 meters are already there when they coalesce here. Okay. Now we have to find how much time will these two particles take to reach C, which is further how much? It is 0.5, 1.5, 2 meters. So remaining is 1.25 meters. Yeah. Total was 3.25 meters, right? Yeah, total was 3.25 meters. 2 meters gone, 1.25 meters to cover. Okay. Now we'll find the acceleration. Let's hope it remains this, but we'll find out. Okay. So the velocity for P at this particular place when they coalesce, what was the velocity? Okay. So it will be V equal to U plus AT again. So V equal to U was how much when it started from here? 3. Acceleration was 4 now. Time is 0.5 seconds. So it will be how much? 2 plus 3, 5 meters per second. What was the velocity of Q? Which is 2. It was in a initial velocity 4 times 0.5, which is 4 meters per second. Now, since they have collided, we will use conservation of momentum. To find what will be their combined velocity. So m is the mass of the first one, its velocity is 5, plus m, its velocity is 4. Obviously both are going in the same direction, so they will coalesce. M plus m, both have same mass, and let's see what will be their velocity. So 9m equal to 2mv. So m and m cancel both sides. V equal to 9 over 2, which is 4.5 meters per second. Right? Now our challenge is from this point of colliding, how much time will they take to cover 1.25 meters? So S is 1.25 meters. V is, rather U, it will become U now. We are starting from here. U is 4.5 meters per second. Okay. And we do not know what will be velocity later, but acceleration we can find again. So this question has many layers. So after they have become one body, we'll use the same ma equal to applied force. Applied force will be their masses times 10 and sine component, which was 3 over 5. Yes, that is the only one that will take them down. Okay. And there is resistive force, which is mu times m times 10 cos theta, which is 4/5. All have m, so let's get rid of m. And did I write 2m here? I should have written 2 also. So 2m, 2 also goes. So a equals to 6 minus 0.25 times 8 is 2, equal to 4 meters per second square. That's the acceleration which we will use here. Now here we can use the formula s equal to ut plus half at square, because time is the only thing we need to know now, and everything else we know. We know s 1.25 equal to u is 4.5, which we got from here. T we don't know it, plus half acceleration is known to us now, 4 got here, and t square. So this will cancel and it will become a quadratic equation. Everything will be on the left side, so I'll write 2t square first plus 4.5 t, and this will become negative minus 1.25 equal to 0. This becomes the quadratic equation, which I will solve with the help of a quadratic formula. 2.5, I don't think it will be possible to by splitting the middle term, so I'll do quadratic formula. Minus b plus minus, I will not write minus for a reason I will tell you later, minus b plus b square minus 4 times a times c divided by 2a. Why did I ignore negative? Because this is negative, that will be negative, so negative and negative will be give me a negative numerator divided by positive denominator. That means time will be negative, and time cannot be negative in this case. So I'm just taking the positive one, which will give me positive. So minus 4.5 plus 20.25 minus 8 times 10, this one positive 10, over 4. Minus 4.5 plus square root 30.25 divided by 4. What do we get here? Minus 4.5 plus 5.5. Guys, you can use your calculator if it seems to be too long. So 1 over 4. We got time equal to 0.25 seconds, or 1 over 4 seconds. That time it will take for both the particles to travel from this particular place where they coalesce to point C. This concludes the solution video of this paper. I hope you liked it. If you did, give it a big thumbs up and subscribe to Math United. If you do, it will motivate me to make many more videos like this in future too. Thank you so much.